Yeah,
Yes,
we can start off, sir.
Sure, I'm just typing in the message. So once they
Okay.
are available, I'll paste it here so that they can refer it to that.
Okay. Okay.
One moment. So we are on the chapter named Triumphant. The young engineers, 280 to be precise, changed the dynamics of DRDL. It was a valuable experience for all of us. We were now in a position to develop through these young teams a re entry technology unstructured, a millimetric wave radar, a phased array radar, rocket systems, and other such equipment. When we first assigned these tasks to these young scientists, they did not fully grasp the importance of their work. Once they did, they felt uneasy under the burden of the tremendous faith placed in them. I still remember one young man telling me, "There is no big shot in our team. How will we be able to break through?" I told him, "A big shot is a little shot who keeps on shooting, so keep trying." It was astonishing to see how, in the young scientific environment, negative attitudes changed to positive, and things that were previously thought impractical began happening. Many older scientists were rejuvenated simply by being part of a young team. It has been my personal experience that the true flavor, the real fun, the continuous excitement of work lie in the process of doing it rather than having rather than in having it over and done with. To return to the four basic factors that I am convinced are involved in successful outcomes: goal setting, positive thinking, visualizing, and believing. By now, we had gone through an elaborate exercise of goal setting and enthused the young scientists about these goals. At the review meetings, I would insist that the youngest scientists present their team's work. That would help them in visualizing the whole system. Gradually, an atmosphere of confidence grew. Young scientists started questioning senior colleagues on solid technical issues. Nothing daunted them because they feared nothing. If there were doubts, they rose above them. They soon became persons of power. A person with belief never grovels before anyone, whining and whimpering that it's all too much, that he lacks support, and he is being treated unfairly. Instead, such a person tackles problems head on and then affirms, "As a child of God, I am greater than anything that can happen to me." I try to keep the work environment lively with a good blend of the experience of the older scientists mixed with the skills of their younger colleagues. This positive dependence between youth and experience had created a very productive work culture at DRDL. The first launch of the missile program was conducted on 16 September 1985 when Trishul took off from the test range at Sriharikota called SHAR. It was a ballistic flight meant for testing in flight performance for the solid propellant rocket motor. Two C-band radars and theodolite KTLs were used to track the missile from the ground. The test was successful. The launcher, rocket motor, and telemetry systems functioned as planned. The aerodynamic drag, however, was higher than the estimates predicted on the basis of wind tunnel testing. In terms of technology, breakthrough, or experience enrichment, this test was a little value. This test was of little value, but the real achievement of this test was to remind my DRDL friends that they could fly missiles without being driven by the brute demands of compliance or reverse engineering. In a swift stroke, the psyche of the DRDL scientists experienced a multidimensional expansion. This was followed by the successful test flight of the pilotless target aircraft PTA. Our engineers had developed the rocket motor for the PTA designed by the Bangalore based Aeronautical Development Establishment ADE. The motor had been type approved by DTD and P establishment AIR Air. This was a small but significant step towards developing missile hardware that is not only functional but also acceptable to the user agencies. A private sector firm was engaged to produce a reliable, airworthy, high thrust to weight ratio rocket motor with technology input from DRDL. We were slowly graduating from single laboratory projects to multi laboratory projects to laboratory industry exercises. The development of PTA symbolized a great confluence of four different organizations. I felt as if I was standing at a meeting point and looking at the roads come from ADE, DTD, and P, that is AIR and ISRO. The fourth road was the DRDL, a highway to national self reliance in mission technology. Taking our partnership with the academic institutions of the country a step further, joint advanced technology programs were started at the Indian Institute of Science, IISc, and Jadavpur University. I have always had a deep regard for academic institutions and reverence for excellent academicians. I value the inputs that academicians can make to development. Formal requests had been placed with these institutions and our arrangements arrived at under which expertise from their faculties would be extended to DRDL in pursuance of its projects. Let me highlight a few contributions of academic institutions to the various missile systems. Prithvi had been designed as an inertially guided missile. To reach the target accurately, the trajectory parameters have to be loaded into its brain, an onboard computer. A team of young engineering graduates at Jadavpur University, under the guidance of Professor Ghoshal, developed the required robust guidance algorithm. At the ISC, postgraduate students under the leadership of Professor I.G. Sharma developed air defense software for multi target acquisition by Akash. The re-entry vehicle system design methodology for Agni was developed by a young team at IIT Madras and DRDO scientists. Osmania University's Navigational Electronics Research and Training Unit had developed state-of-the-art signal processing algorithms for NAG. I have only given a few examples of collaborative endeavor. In fact, it would have been very difficult to achieve our advanced technological goals without the active partnership of our academic institutions. Let us consider the example of the Agni payload breakthrough. Agni is a two-stage rocket system and employs re-entry technology developed in the country for the first time. It is boosted by a first stage solid rocket motor derived from SLV-3 and further accelerated at the second stage with the liquid rocket engines of Prithvi. For the Agni, the payload gets delivered at hypersonic speeds, which calls for design and development of a re-entry vehicle structure. The payload with guidance electronics is housed in the re-entry vehicle structure. which is meant to protect the payload by keeping the inside temperature within the limit of 40 OC when the outside skin temperature is greater than 2500 OC. An inertial guidance system with an onboard computer guides the payload to the required target. For any re-entry missile system, three-dimensional performs are core material for making the carbon nose step that will remain strong even at such higher temperatures. Four laboratories of DRDO and the CSIR achieved this in short span of 18 months, something other countries could do only after a decade of research and development. Hello,
Hello.
can I just take a quick break? Couple of
Yeah,
minutes. I
so
just
far.
need to. Yeah, thank you. And Taranjit, ma'am, how do you think this is going? Is it composed
Very
enough
well,
or?
very well. No, no,
All
very
right,
well. You are doing it at a very good pace, not too fast, not too slow. And your voice is also very, very clear.
all right. Yeah, thank you, ma'am. Thank you. It's just that was running in my background, whether it's
No,
too
sir.
fast or.
No, sir. No, sir, you are reading very well. Very well.
All right. Yeah, thank you, ma'am. All right, continuing further. Another challenge involved in the Agni payload design was related to the tremendous speed with which it would re enter the atmosphere. In fact, Agni would re enter the atmosphere at 12 times the speed of sound, 12 Mach as we call it in science. At this tremendous speed, we had no experience of how to keep the vehicle under control. To carry out a test, we had no wind tunnel to generate that kind of speed. If we sought American help, we would have been seen as aspiring to something they considered their exclusive privilege. Even if they consented to cooperate, they would be certain to quote a price for their wind tunnel greater than our entire project budget. Now, the question was how to beat the system. Professor S.M. Deshpande of the IISc found four young, bright scientists working in the field of fluid dynamics and within 6 months developed the software for computational fluid dynamics for hypersonic regimes, which is one of its kind in the world. Another achievement was the development of a missile trajectory simulation software, Anukalpana, by Professor I.G. Sharma of IISc to evaluate multi-target acquisition capabilities of an Akash-type weapon system. No country would have given us this kind of software, but we developed it indigenously. In yet another example of creating a synergy of scientific talent, Professor Bharati Bhatt of IIT Delhi, working with the Solid Physics Laboratory SPL and Central Electronics Limited CEL, broke the monopoly of the Western countries by developing ferrite phase shifters for use in the multifunction multitasking 3D phased army radar for surveillance, tracking, and guidance of Akash Professor Saraf of IIT Kharagpur, working with BK Mukhopadhyay, my colleague at RCI, made a millimetric wave (mmW) antenna for the Nag Seeker head in 2 years, a record even by international standards. The Central Electric and Electronics Institute CEERI, Pilani developed an impact diode in consortium with the SPL and RCI to overcome technological foreign dependence in creating these components, which are the heart of any MMW device. A work on the project spread horizontally, performance appraisal became more and more difficult. DRDO as an assessment linked policy, leading nearly 500 scientists, I had to finalize their performance appraisals in the form of annual confidential reports, ACRs. These reports would be forwarded to an assessment board comprised of outside specialists for recommendations. Many people viewed this party of my job uncharitably. Missing a promotion was conveniently translated as dislike I had towards them. Promotions of other colleagues were seen as subjective favors granted by me. Entrusted with the task of performance evaluation, I had to be a fair judge. To trust To truly understand a judge, you must understand the riddle of the scales. One side heaped high with hope, the other side holding apprehension. When the scales dip, bright optimism turns into silent panic. When a person looks at himself, he is likely to misjudge what he finds. He sees only his intentions. Most people have good intentions and hence conclude that whatever they are doing is good. It is difficult for an individual to objectively judge their actions, which may be and often are contradictory to his good intentions. Most people come to work with the intention of doing it. Many of them do their work in a manner they find convenient and leave for home in the evening with a sense of satisfaction. They do not evaluate their performance, only their intentions. It is assumed that because an individual has worked with the intention of finishing his work in time, if delays occurred, they were due to reasons beyond his control. He had no intention of causing the delay, but if his action or inaction caused that delay, was it not intentional? Looking back on my days as a young scientist, I am aware that one of the most constant and powerful urges I experienced was my desire to be more than what I was at that moment. I desired to feel more, learn more, express more. I desired to grow, improve, purify, expand. I never used any outside influence to advance my career. All I had was the inner urge to seek more within myself. The key to my motivation has always been to look at how far I had still to go rather than how far I had come. After all, what is life but a mixture of unsolved problems, ambiguous victories, and amorphous defeats? The trouble is that we often merely analyze life instead of dealing with it. People dissect their failures for causes and effects, but seldom deal with them and gain experience to master them and thereby avoid their recurrence. This is my belief that through difficulties and problems, God gives us the opportunity to grow. So when your hopes and dreams and goals are dashed, search amongst the wreckage. You may find a golden opportunity hidden in the ruins. To motivate people to enhance their performance and deal with depression is always a challenge for a leader. I have observed an analogy between a force field equilibrium and resistance to change in organizations. Resistance to change in organizations. Let us imagine change to be a coiled spring in the field of opposing forces, such that some forces support change and others resist it. By increasing the supportive forces such as supervisory pressure, prospects of career growth, and monetary benefits, or decreasing the resisting forces such as group norms, social rewards, and work avoidance, the situation can be directed towards the desired result for a short term only, and that too only to certain extent. After a while, the resisting forces push back with a greater force as they are compressed even more tightly. Therefore, a better approach would be to decrease the resisting force in such a manner that there is no concomitant increase in the supporting forces. In this way, less energy will be needed to bring about and maintain change. The result of the forces I mentioned above is motive. It is a force which is internal to the individual and forms the basis of his behavior in the work environment. In my experience, most people possess a strong inner drive for growth, competence, and self actualization. The problem, however, has been the lack of work environment that stimulates and permits them to give full expression to this drive. Leaders can create a high productivity level by providing the appropriate organizational structure and job design, and by the acknowledging and appreciating hard work. I first attempted to build up such a supportive environment in 1983 while launching IGMDP. The projects were in the design phase at that time. The organization resulted in at least 40% of to 50% increase in the level of activity. Now that the multiple projects were entering into the development and flight testing stage, the major and minor milestones reached gave the program visibility and continuous commitment. With the absorption of a young team of scientists, the average age had been brought down from 42 to 33. I felt it was time for a second reorganization, but how should I go about it? I took stock of the motivational inventory available at that time. Let me explain to you what I mean by this term. The inventory of a leader is made up of three types of understanding: an understanding of the needs that people expect to satisfy in their jobs, an understanding of the effect that job design has on motivation, and an understanding of the power of positive reinforcement in influencing people's behavior. The 1983 reorganization was done with the objective of renewal. It was indeed a very complex exercise handled deftly by A.V. Rangarao and Colonel R. Swaminathan. We created a team of newly joined young scientists with just one experienced person and gave them the challenge of building the strap down inertial guidance system, an onboard computer, and a RAM rocket in propulsion system. These exercises were being attempted for the first time in the country, and the technology involved was comparable with world class systems. The guidance technology is centered around the gyro and accelerate accelerometer package, and electronics to process the sensor output. The onboard computer carries the machine computations and flight sequencing. A RAM rocket system breathes air to sustain its high velocity for long durations after it is put through a booster rocket. The young teams not only designed these systems but also developed them into operational equipment. Later, Prithvi and then Agni used similar guidance systems with excellent results. The effort of these young teams made the country self reliant in the area of protected technologies. It was a good demonstration of the renewal factor. Our intellectual capacity was renewed through contact with enthusiastic young minds and had achieved these outstanding results. Now, besides the renewal of manpower, emphasis had to be laid on augmenting the strength of project groups. Often people seek to satisfy their social, egoistic, and self actualization needs at their workplaces. A good leader must identify two different sets of environmental features: one which gives satisfies a person's need, and the other which creates dissatisfaction with his work. We have already observed that people look for those characteristics in their work that relate to the values and goals which they considered important as giving meaning to their lives. If a job meets the employee's need for achievement, recognition, responsibility, growth, and advancement, they will work hard to achieve goals. Once the work is satisfying, a person then looks at the environment and circumstances in the workplace. He observes the policies of the administration, qualities of his leader, security, status, and working conditions. Then he correlates these factors to the interpersonal relationships he has with his peers and examines his personal life in the light of these factors. It is agglomerate of all these aspects that decides the degree and quality of person's effort and performance. The matrix organization evolved in 1983 proved excellent in meeting all these requirements. So, while retaining the structure of the laboratory, we undertook a task design exercise. The scientists working in technology directorates were made system managers to interact exclusively with one project. An external fabrication wing was formed under P.K. Biswas, a developmental fabrication technologist of long standing, to deal with public sector understandings, PSUs, and private sector firms associated with the development of the missile hardware. This reduced pressure on the in house fabrication facilities and enabled them to concentrate on jobs which could not be undertaken outside, which in fact occupied all the three shifts. Work on Prithvi was nearing completion when we entered 1988. For the first time in the country, clustered liquid propellant LP rocket engines with programmable total impulse were going to be used in a missile system to attain flexibility in payload range combination. Now, besides the scope and quality of the policy decisions, Sundaram and I were providing to the Prithvi team the project's success dependent on creative ideas being converted into workable products and the quality and thoroughness of the team members' contribution. Saraswat with Y. Gnaneshwar and P. Venugopalan did a commendable job in this regard. They instilled in their team a sense of pride and achievement. The importance of these rocket engines was not restricted to the Prithvi project, it was national achievement. Under their collective leadership, a large number of engineers and technicians understood and committed themselves to the team goals as well as specific goals which each of them was committed to accomplish personally. Their entire team worked under a self evident sort of direction, working together with the ordnance factory, Turkey. They also completely eliminated the import content in the propellant for these engines. Leaving the vehicle development in the safe and efficient hands of Sundaram and Saraswat, I started looking at the mission's vulnerable areas. Meticulous planning had gone into the development of the launch or release mechanism LRM for the smooth liftoff of the missile. The joint development of explosive bolts to hold the LRM prior to the launch by DRDL and Explosive Research and Development Laboratory ERDL was an excellent example of multi work center coordination. While flying, drifting into spells of contemplation and looking down at the landscape below has always been my favorite preoccupation. It is so beautiful, so harmonious, so peaceful from a distance that I wonder where all those boundaries are which separate district from district, state from state, and country from country. Maybe such a sense of distance and detachment is required in dealing with all the activities of our life. Since the interim test range at Balazor was still at least a year away from completion, we had set up special facilities at SHAR for the launch of Prithvi. These included a launch pad, blockhouse, control consoles, and mobile telemetry stations. I had a happy reunion with my old friend M.R. Kurup, who was the director. Shar centered by then, working with Kurup or the Prithvi launch campaign gave me a great satisfaction. Kurup worked for Prithvi as a team member, ignoring the boundary lines that divide DRDO and ISRO, DRDL and SHAR. Kurup used to spend a lot of time with us at the launch pad. He complimented us with his experience in range testing and range safety and worked with great enthusiasm in propellant filling, making the maiden Prithvi launch campaign a memorable experience. Prithvi was launched at 11:23 hours on 25th 25 February 1988. It was an epoch making event in the history of rocketry in the country. Prithvi was not merely a surface to surface missile with the capability of delivering a 1000 kg conventional warhead to a distance of 150 km with an accuracy of 50-meter CEP. It was, in fact, the basic module for all the future guided missiles in the country. It already had the provision for modifications from a long range surface to an air missile system and could also be deployed on a ship. The accuracy of a missile is expressed in terms of its circular error probable CEP. This measures the radius of a circle within which 50% of the missiles fired will impact. In other words, if a missile has a CEP of 1 kilometer, such as the Iraqi Scud missiles fired in the Gulf War, this means that half of them should impact within 1 kilometer of their target. A missile with a conventional high explosive warhead and a CEP of 1 kilometer would normally be expected to destroy or disable fixed military targets such as a command and control facility or an airbase. It would, however, be effective against an undefined target such as a city. The German V-2 missiles fired at London between September 1944 and March 1945 had a conventional high explosive warhead and a very large CEP of some 17 kilometers. Yet the 500 V2s which hit London succeeded in causing more than 21,000 casualties and destroying about 200,000 homes. When the West when the West were crying themselves hoarse over the NPT, we stressed upon building competence in core guidance and control technologies to achieve a CEP as precise as 50 meters. With the success of the Prithvi trials, the cold reality of a possible strategic strike, even without a nuclear warhead, had silenced the critics to whisper about a possible technology conspiracy theory. The launch of Prithvi sent shockwaves across the unfriendly neighboring countries. The response of the Western Bloc was initially one of shock and then of anger. A seven nation technology embargo was clamped, making it impossible for India to buy anything even remotely connected with the development of guided missiles. The emergence of India as a self reliant country in the fields of guided missiles upset all the developed nations of the world.
Mr. Naresh, if it ends a paragraph or this thing, we can stop here and we'll have a short discussion.
Sure, ma'am. It
Okay.
ends here.
Okay. Then we can have a short discussion and we can close the meeting.
Sure, ma'am.
Okay. So let me take the floor and I'll say that, it's extremely, extremely heartening that, we have crossed so many barriers and so many uh, things kept in our way to achieve what we have. And it makes me so happy that we have such an amazing team of dedicated scientists and who literally never allowed anything to stop them. Um, Mr. Taranjit and Mr. Naresh, you can give your takeaways too. I would love to hear that.
Right. What I sensed was also the enthusiasm of the scientists that they never wanted to give up or never, even in at times when they were questioning their own uh, success or when they were faced with challenges, they had a particular team or a leadership quality which wanted them to take it further, is what I could sense from the entire paragraph what I read. And here it also spoke about where Abdul Kalam ji said he had to um, like review others' performance, rate others, and to give them appraisal or to promote them. So I guess it was not a challenge. It was indeed a challenging task to promote one set of people and not to promote other set of people. As he says, it is others might consider that they have not done well. So I think that's also a task where he had to put his own mind through and review the performance.
Yeah, even that kind of stood out for me. It's such a difficult place to be in, where you're being fair and you're not being, and how to be fair also is a huge issue, especially for people in leadership roles. How not to let your emotions rule you.
Hmm. And it
So,
makes more sense that sorry, go ahead.
no, please, please, please.
Yeah, I was thinking like it because everybody is working to as a team to achieve one set of goal here, and everybody does give their best. And sometimes when Abdul Kalam ji says some people set for promotion and some people, it shouldn't be taken as a disheartening moment that they are not promoted, or it shouldn't be seen as, oh, they have failed at some level. It should be taken as a challenge or something, is what I think he stresses on.
Yeah, and that's an amazing thing, isn't it? Truly amazing how you have such an amazing work culture where everybody is taking it more like a something to achieve rather than okay, be disappointed about.
Exactly.
Yeah, wow. Seriously. Taranjit, would you like to go?
Yeah. Uh, I would like to say the things like throughout what I have we have been reading, apart from the technological part, the technical parts, Sir has mentioned about the leadership qualities, how the leaders should be. But here in this paragraph, in this piece of the lesson that we have read, he has also explained us what do the employees expect, what there are what do they want from their work life, the social, egoistic, and self actualization needs at their workplace. If that are not fulfilled, the work life becomes very boring. You don't feel like working a lot. And as Sir said, and you also said, capsizing the size where he has said from 42 to 33, it was really very difficult for him to resize uh, the organization. How, and one very beautiful thing which I have been telling people, those who are around me, is when the fresh people, those who come, we should give them a chance. We should give them a free hand to work. Like it was, he has said that some new appointees, those who had been done, they were given a project that they have to make a gyro, where is it? Yeah, a ram rocket propulsion, and a challenge of building a strap down inertial guidance system and onboard computer. So these people, those who have come with fresh ideas, they put life into the organization. If we see also, like when you promotions usually come later in life, but nowadays the West has given this concept to us that initially when say in the age group of 25 to 35, we have many CEOs nowadays, and this was not possible say 25 30 years back. It was not done at that time. So this is something really very great, that new people are given chance. So if new people are given chance, old ones with the experience and the new ones with the newer ideas, they can gel and make the best, make out the best things that are available to them, and the organization rises. This is what I feel it is.
Yeah, yes, ma'am. Even I was thinking, um, I mean, this is what I'm trying to speak is a little off from the book. But two things that I observed when you were saying is one, there will be a time or an opportunity where we will have to work with our younger generation as well. And it should not be taken uh, as something down about, feel down about ourselves, but instead work and gel with them to learn from them and to uh, work as a team, be open for their feedback, their views as well, instead of I mean that now the time has come where 25 years old CEOs are there, and we don't really shouldn't feel bad about ourselves being at 30s or 40s, and I think we should work as a team.
Yes, when say I would say 25 years back or 30 years back, majorly, if you see, then we had, there were no foreign investments, there were not corporates were not there. Now, when this corporate life came, like foreign investments came, and they had their own rules and regulations, only then this change came. In the system of bureaucracy that we had previously, in it was that you have to rise every rung of the ladder, and by the time you reached like many of them never reached the top. But now this performance level, performance based promotions, this really gave a new life to many organizations. So this the government also saw, and then 50% or say 60% is still governmental, and 40% they have brought in the private players, so that there is improvement.
Exactly. One more thing, what I noticed was this kind of uh, downsizing from the age of 42 to 33 was which was implemented by Abdul Kalam Sirji was, I mean, this is again off topic, but I see it happened in 2007 in Cricket World Cup as well, where Mahendra Singh Dhoni was brought up this kind of plan where he dropped senior players who were slow to. I mean, it was a time where younger players had to be given chance, and there were times where senior players should have been dropped and brought younger players. And I think he did not uh, question his ability or its decision once, and it did take the decision, and it worked out in a favor where we won the World Cup. I think these changes by the mindset, I think, is required, is what I feel. I don't know if it was um, I that's just the outside of the box, which I think I could relate it to.
Definitely, there are some things that we need to change. Definitely, experience has no alternative. Experience definitely counts, but then you don't have to be stubborn. You don't have to be stagnant. It should always be flowing. That is what I feel. Like if you become stagnant, no, you have to 101% stick by the rules. Then the progress becomes a difficult thing to achieve.
Right, ma'am.
Yeah. Kanti ma'am, can we call it a day today? Kanti ma'am?
I was mostly in the reading mode, so I could not really make a lot of
Yeah,
points.
it always happens, sir. When we are reading, we don't realize, but when we are listening, we can understand more. But then,
Yeah,
both ways, it is enlightening. If you read, then you come to know that yes, this was the point which I had, I had read, but then I missed it out. While speaking, missed it out.
I mean, this thing, this part of reading for others, I think I will learn from doing it while reading for the others, also try to make points in my own head. I think that will come
Yes,
with experience, because I see
yes,
I could know, I could only read but not register points as clearly as I was reading.
yes. It's a really a beautiful experience, reading and listening. It's really a very beautiful experience.
Nice,
Many a time,
nice.
like when we are explaining something to somebody, so we just read very few lines. But here we read large paragraphs, and then many a times we forget what we have read. So, and recollect it later on that yes, we had read this.
And there was too much technical aspect of it today.
Too much of technical aspects this book has, but the in between the technical things, the social life, the work life, the
Yeah,
experiences sir has shared, that is incomparable. It's really
definitely.
incomparable.
No doubt. And I truly tell you, I was hesitant because of the fact that there's so much of technical jargon in it. But then I realized that man literally is the president of India. So
Yes,
we just
I
have to go through it.
the most humble person in bureaucracy, I would say, the most humble
Yes.
person.
Yes.
It is very difficult to find very few leaders we can name like him, where, say, Sardar Manmohan Singh or Atal Bihari Vajpayee, Dr. Rajendra Prasad, or Lal Bahadur Shastri. We have a very handful of such great leaders. Very
Yes.
only.
Yes.
Yeah.
Truly. Anyway, thank you so much for both of you. You had it was a lovely, lovely discussion and lovely, lovely points where each of you made. And as I said, this has become literally my favorite part of working with Asha. Literally, hands down. Yes.
Yeah.
Thank you so much for making it
I was
interesting.
so tired today. Like I had a very long day, and I thought I will not end the meeting. But this reading is something so close to my heart. I said nothing doing. I have to attend it, and then let's see what will happen.
Yes. Thank you so much, Mr. Naresh sir, and thank you, Staranjit. Sandhya, you can close the meeting. Thank you.
Thank you so